Morning, everybody. I want to do a quick walkthrough of our conservation of energy lesson. So, if you're joining us, thanks for taking the time. So, on this one, there's a couple ways to talk about conservation of energy. We've seen it in other places. So, that word conservation always means in physics that whatever it's talking about is staying the same. So, we can say energy is never created or destroyed, it is only transformed. And you're going to see a lot of transformations going from potential energy to kinetic, or you might go from kinetic energy back to potential. So we'll show some examples of that later. Uh, Another simple way of thinking that is whatever amount of energy you start with, and it might be, we call that amount of energy E total, is what you're going to end with. So we can write that the energy initial in the system is going to equal the final energy, and we can write that quickly as EI equals EF. And again, the idea is that energy is never lost. Whatever energy you start with is what you end with. So uh, we have three types of energy we'll be tracking. We have our potential energy, which is mostly due to height or location. We have kinetic energy, which is due to the motion of the object, so it has to be moving, has to have a velocity. And then you will see some spring energy show up. It's not going to show up in the first two assignments, but it might show up later. So, and that's 1/2 K, which is called the spring constant, times the amount of stretch or the amount of compression squared. So that's our three types of energy we'll be using for conservation of energy. There are lots of other types. We're just going to restrict ourselves to these three, though. So no thermal or other types like that. The next one is a quick example. Let me go back here. So we have a ball rolling down a ramp or an incline. And the question is, where is the potential energy the largest and where is the kinetic energy the largest? And so as we kind of watch this on the next slide, so we can make up a number, and you're going to see that initially at the top, if it starts from rest and then it rolls down, it starts with all potential energy. And then as it rolls down, it's going to speed up and it's going to lose potential energy and gain kinetic. So if we halfway down, it's going to be 50-50, 250 joules and 250 joules in this case. And there's nothing specific about these numbers. And then as it reaches the bottom, it's going to switch. So all of the potential energy, we'll call this height of zero. So there's no potential energy, and all of the energy of the system is in kinetic. If you add these two, kinetic energy plus potential, together, you'll notice the total energy for this system always stays at 500 joules. And that's the concept you're going to see with this conservation of energy, that the total energy in the system always stays the same. If we do another example, we have a high diver diving off a platform, which is essentially the same problem as the ball rolling down the ramp. He starts up high. As he jumps off, he's going to speed up and he's going to convert the potential energy into kinetic. If we watch this one, so he starts with 10,000 joules of potential energy. And again, that number is just for this system. He has no kinetic because he's not moving. As he falls down 1/4 of the way, you'll see 25% is kinetic, 75% is potential. And then in the middle, the energy is shared 50-50. And then at the bottom, the energy is again all converted to kinetic. And this is just before he hits the water. Once he hits that little bucket, or if you jump into a pool, your kinetic energy will be transformed into sound, into moving the water, into other forms, but those are harder to track mathematically. One thing you might notice is we're not including the effects of air resistance or friction on a surface. And so those are two things that do exist in real life, but we're not going to include them in our calculations. So we're going to assume that all the, as an object rolls down, all the kinetic energy is converted to potential. So there isn't any that's being transferred to thermal energy in our examples. So mathematically, for most of the problems this week, we're going to focus on kinetic energy and potential. The initial energy is going to equal the final energy.